In this video, we're going to take a look at finding the quotient of two functions, the derivative of the quotient of two functions. And so if both f and g are differentiable functions, so we can take their derivatives, and at all values for x for which g of x is not 0, then our derivative is f of x. Derivative of f of x over g of x is the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function, all over the bottom function squared. And so we can say it is the bottom function low d high minus high. So the bottom function times the derivative of the bottom times the derivative of the top, low d high, minus high d low, square the bottom, and away we go. That is our quotient rule. So here, let's look at an example. Here we have y is equal to, our top function is 3x squared minus 2x. Our bottom function is x cubed plus 7. So when we take our derivative, we have low, the bottom function, d high times the derivative of the top. So 3x squared, the derivative of 3x squared is 6x. We bring the power down, subtract 1 from the power, minus derivative of 2x is 2. So low d high minus high, so the top function unchanged, d low times the derivative of the bottom. Derivative of the bottom is 3x squared plus 0, so I'll just leave it as 3x squared, all over the bottom function squared. And I will leave it like that. In some cases, depending on your setting, you might try to do some simplification on top. You could possibly get some stuff after you clean this up. You might be able to get a little bit of cancellation. I really would very, very rarely FOIL out the bottom, because what I would hope to happen if I'm doing any further work is that stuff up here will somehow cancel with the stuff on bottom. Some of the stuff maybe. But in general, that's not expected to happen. Let's look at our second example. Here we have f of x is x sine x over 2x plus 1. So we have a quotient. We're going to take the derivative. So it's the bottom function, low, d high. So bottom function times the derivative of the top. The top is x times sine x. So we have the product of two functions. So we need to use our product rule. Our product rule says it's the first function, x, times the derivative of the second. So x times derivative of sine is cosine, plus the second times the derivative of the first. That is, so far we've done low, d high. Then we need to go minus the top function, x sine x, times the derivative of the bottom. The derivative of 2x plus 1 is the derivative of 2x is just 2. And the derivative of 1 is 0, so 2 plus 0. All of this is over the bottom squared. That is our derivative. So these quotient rules and product rules and sum and difference rules, power rules, constant multiple rules, they start to come up in all kinds of different settings and different orders, and we just have to take them piece by piece. As you're saying, we need to take the derivative of this piece. You need to ask yourself, what rules do I need to use for this piece? Right? So this second example, when we rolled through it, we initially said we're using the quotient rule, and that was fine and good. We did low times the derivative of the top. And so we said, all right, to take the derivative of the top, what derivative rule do we need to take? Right? So this is within our quotient rule, taking the derivative of the top, we have a product rule. And so it's the first times the derivative of the second plus the second times the derivative of the first. That is a times there. So it was a times 1. All right. In our next video, we'll take a look at some other examples of some trig functions, trig derivatives. We will see you there.